Let's look at the momentum lab here. This is the basic idea, is that we're going to take a glider. This glider is going to be moving. This guy's going to be sitting still. And when they collide, the velocity basically is just cut in half, or roughly in half, because those gliders have about the same mass. So the idea here is that a small glider, a small amount of mass moving fast, has possibly the same momentum as a large mass moving more slowly. Okay, and that's what we're going to test. We're not going to assume that momentum is conserved. We're just simply going to calculate the momentum before and the momentum after, and see if they could possibly be the same. Okay, so what we'll do here is we need the blue pen. There we go. This is, let's call this M1 and this one's M2, right? Well, this guy has no momentum. This guy's moving maybe at, we'll call it V1, right? We'll say these guys are moving at V2, and here's M1 plus M2, right? So the question is, does this momentum, is that the same as this momentum? Now, of course, in a real laboratory, they're not going to be the same. You can't just calculate the momentum and go, oh, well, this number is slightly different from that number. So we're going to have to figure out the uncertainty. This is going to have to be the initial momentum plus or minus some uncertainty of momentum. And this is going to be the final momentum plus or minus an uncertainty of momentum. Okay? And then we have to make a clever mathematical argument as to whether these could possibly overlap. Okay? Now, if the uncertainties don't overlap, then we've proven that momentum in this collision was not conserved. And that's all we can prove. In science, all we can prove in science is that we can prove things wrong, okay? But we can't prove that they're right. In other words, if they do overlap, we haven't proven that they're right. We've just shown that they could possibly be the same. Now, the way science works is if a theory like evolution fails to be disproven long enough and makes enough testable predictions, and we check all those predictions and it looks like it's right, we eventually elevate it from hypothesis to theory. Okay, so that's the course of science. If we fail to disprove something long enough, it becomes a theory. Okay, and theory is, people like throw the word theory out as if it's this hypothetical thing, but it's not. That's hypothesis, right? Theory is, that's what we've got. Gravity is a theory. Okay.